In this next section, we're going to continue studying hypothesis tests, but what's different is we're not looking at one sample, but we're looking at two. We're going to be comparing two different proportions. So let's start with the question. Is there a difference between employees and customers wearing masks? When you enter a grocery store these days, masks tend to be a thing. And this would be interesting to know if there's a difference between these two populations. So with all hypothesis tests, let's turn this into our null and alternative. Now, one thing we're used to in doing a single sample is we were often given a percentage to work with. But we're not necessarily given one when we're comparing two groups. We want to just see if they're different or if one's bigger or less than the other. So, because we're talking about proportions, I am still using the letter P without a hat. That represents a population. And what we're looking for are there's two different groups. There's the employees and customers. So I could even use a little sub E to stand for the proportion of employees is equal to the proportion of customers. Remember, the null always gets the equal sign. The question's asking if there's a difference between them. So we have no indication that one group wears them more than another group. We just want to know, are they different or are they equal? And not equal says there's a difference between these two groups. All right. So one thing you're seeing for the first time is there are two different proportions represented in the null and alternative, and notice there is not a number represented here. Well, the next thing we usually do is go get some data or evidence to see if we can support the alternative. Otherwise, we always stick with the null. So let's say we've got my two groups. So let's say we've got my employee. Let's start with the customers. I've got my customers, and I've got a group employees, and the data starts with how many customers did we survey. Let's say there were 40 that we observed. How many were wearing masks? Let's say 36. And so we need a sample proportion that were wearing masks. If you divide 36 by 40, you'll get 90% or 0.9. Employees, let's say there were 50 employees observed, and of them 40 were wearing masks. The sample proportion for those employees, 40 divided by 50 is 80% or 0.8. Now, I could put a little C, just remind us that's for customers, E for employees, but the question we ask right now, is there a difference in the sample proportions? And all we have to do is look at these two numbers. My two sample proportions, is there a difference? Clearly there is. And that's my point estimate. There's a difference of 10%. And so the answer is yes. 0.9 minus 0.8 is 0.1. So there is a difference. So right now, my evidence should always support my alternative. Yeah, they're not the same. The bigger question we're trying to answer, though, with the hypothesis test is always this. Is there a difference in the population proportions? That's what we're trying to answer. My evidence clearly shows a difference, but I don't care about these 90 people. I want to know, is this true overall? And the answer for this right now is we don't know yet. And that's why we need a test. So let's head to our normal curve and start labeling things. What do we know right now? Well, one thing we usually write down here is we might normally write the word proportion. I want to write the word, this is actually the difference in proportions. Or it's all of my p hat C's minus my P hat E's. It's all my sample differences along this line. But what goes right down the middle, remember, is the null. If I go back to my null, and if you tell me my two population proportions are equal, what would their difference be? If two things are the same and you subtract them, their difference is 0. So you don't see the 0 in the null, but we know that's what the difference should be if the null is true. The next thing we do is we take my point estimate, the 0.1. Did my samples have a difference? They did, of 0.1 or 10%. So that's somewhere over here. And we draw a line up and we shade that tail. Well, the one thing we've learned previously is in a not equals, this is a two-tailed test, so it didn't matter which group was bigger or less. We also have to assume it could have been the other way around, also with the difference of 10%, but if you're going to label it over here, you would actually say negative 10%, because you're always subtracting customer minus employee. Okay, well, my test statistic, this is my second number line, is my z-score. We don't know what that is yet. This is the moment we head to my calculator, and let's do that right now. So, in previous situations, we know that to do a test, we head to Stat, over to the test menu, and previously we've only hit two buttons before. Either it's a one proportion test or a t-test, which is a one sample mean. Well, we're now doing a two proportion test. So for the first time, we're going to choose number 6. And the layout's pretty friendly. Let's talk about my first group. Let's assume it's my customers. So back up to here, my X 36, my N 40. My second group 40, sample size 50. My alternative was not equals, and we calculate, and there's my final screen. Just let's point out a few things on this screen that we've already seen before. First of all, my two p hats, 90 and 80%. We've never seen this before. Where's that 84% coming from? This is what's called a pooled proportion. We don't need it. It's not a big deal unless we were using formulas, so you can ignore that one. The p that matters for us is this one. That's the same p-value we've met already, and above that is our test statistic, the z-score. So I'm going to grab those two numbers. So 1.30 is my z-score. So let me move this off and add it to my sketch. So 1.30 over here would have been negative. But my p-value, which again is the total area of those two tails, my p-value was 1934. Now, I didn't say this before. I usually forget this. Let's say this test was at our classic 5% significance level. This is where small begins. Any p-value less than 5 is small. Anything above 5 is considered big. So because of that, here comes my decision. My decision is, since my p-value is greater than 5%, that tells me to fail to reject the null. So what's my conclusion? Is we have weak or insufficient evidence to support the alternative. And because of that, it could be true the proportions let me just skip that. Let me just say it out loud. It could be true the proportion of mask-wearing customers and employees are equal. That is what my null is telling me. Hey, one small detail to note in your homework. There is a small condition that has to be met early on, and that is to do a true proportion test is that the proportion of successes and failures has to be greater than 5. What does that mean? Well, if we call wearing a mask a success, clearly we're okay in both cases. 36 and 40 are both greater than 5. But what about what about the number of people who weren't wearing a mask? Well, if 40 out of 50 were wearing a mask, that meant 10 were not. That meets our condition, so we're okay. But over here, 36 were wearing a mask. That only meant 4 were not wearing a mask. That officially didn't meet our condition or our criteria to perform a two-proportion test. I'm not going to make a big deal about that here. If you're asked that in your homework, that is a condition that has to be true, is that both the successes and failures have to at least hit 5. But for what we're doing, that's a minor detail. This is us performing our first hypothesis test comparing two proportions.